Welcome to this session by Intellipaat. I'm glad that you've joined us here today. So today we're going to be talking about big data and the tools related to big data, one of which, one of the most popular ones that are being used today, which is Apache Spark, right? So the topic for today is loading and transforming data using PySpark. So we're going to be doing just that. So before we actually get to the demonstration of how it works, we're going to be actually showing you what Apache Spark is for those of you who do not know about this technology, for those of you who do not know about the tools used in big data today. So let us begin with the definitions. So what is Spark, right? So that is the first question that comes up. So Spark is a software framework that has been developed by Apache. It was originally developed by a university, but it was then adopted. It was then adopted by Apache. Now it's an open source framework that has been developed for cluster-based programming or computing. It was originally developed as an upgrade to Hadoop's MapReduce framework for big data analytics, right? So we're going to be discussing why it is an upgrade to Hadoop's MapReduce framework, and we're going to be understanding how big data processing works in general as we go to the next slide. So Spark for big data, let us understand how Spark works with big data. So originally, what we used to do for big data, now, big data is any data source that is outputting data at a very high rate, like petabytes per second or terabytes per second. And big data is also considered any data that is basically above the size of terabytes or petabytes is called big data because it is of an extremely high size, right? So earlier, we used to use this framework called Hadoop MapReduce to process big data, right? So what Hadoop MapReduce used to do was basically if you had a bunch of computers together, if you had a bunch of servers all connected together, you will basically divide the data that you have to process across all of those computers or servers in equal parts. Once you've divided the data, all of those servers or computers will execute their part of the big data analytics query on the part of the data that they have received in parallel. So that reduces the time that it would have taken to process that big data if we were doing it in a sequence only on one system. So Hadoop MapReduce was the first framework that helped us achieve big data computing with parallel programming, basically. So each node executed their own job. And after all of the jobs were executed, the output was aggregated, it was combined together. And at the end of it, we got the output at a much faster rate, right? So you can see the original framework, big data is here. We pass the data through Hadoop MapReduce framework, right? And we get our desired output. So the problem with Hadoop MapReduce is that it's a primitive technology. It was used in the earlier days when random access memory or RAM or physical memory, as we like to call it, was really expensive. So you must remember a time, if you're familiar with computer hardware, you must remember a time when RAM was extremely expensive. Now it's not that expensive. We have it in plenty amount in almost all mobile phones that we use today. So RAM has gotten a lot cheaper ever since the early days. Earlier, when we used to process big data, every temporary file that we used to create in between our jobs, every temporary output that we used to create in between our jobs was written to the disk. It wasn't, we didn't depend on the RAM. We wrote that output on the disk, the hard drive, right? And then when we needed that intermediate output once again, we basically read that from the disk again and put it back into the RAM. So that is how it used to work, because we didn't have a lot of RAM. So we didn't store anything on the RAM for a really long amount of time. We stored it on the hard drive, right? So after we read it, and then we got our desired outputs. But the problem with this essentially was that there were input-output delays, right? Because every time you're putting the data back into your hard drive and reading it back into your physical memory, there is some lag. There is some input-output delay. So this input-output delay, when you're dealing with extremely large amounts of data, this input output delay can add up to a lot, right? It can increase the time taken by your job by a lot. So we needed a solution for that. So when RAM or random access memory started getting cheaper, when physical memory started getting cheaper, another alternative was developed to Hadoop MapReduce, and this alternative is called Spark. Now, Spark uses a framework called the Spark engine for its processing. The usage of the Spark engine over the traditional MapReduce framework emphasizes on in-memory processing and the usage of shared variables across nodes. This makes Spark about 100 times faster. So how does this Spark work now? So earlier we were writing everything. Every intermediate output was being written onto the hard drive. In Spark, since now RAM is cheap, we store the intermediate output on the RAM itself. We store it on the physical memory of the node itself because we have the ability to, because we have RAM in plenty. So because of this, there is significantly less input output delay because we don't have to write anything much to hard drives anymore. We can simply read our data once from the hard drive, put it into the RAM, process all we have to, and get our output directly. Now, for smaller files, the difference between Hadoop MapReduce and Apache Spark is not at all visible. But when we are talking about files in the terabytes and petabytes, we can almost certainly see that Apache Spark is about 100 times faster in the output that it gives us as compared to MapReduce. Let us look at how normal data is processed. So if you're coming from a data analytics or a data science background, not from a big data background, if you've done something with data analytics or data science, so you must have used these particular technologies like Python and R. These are the most popular technologies for data related subjects, essentially. So data analytics and data science with Python and R. So you have your normal size data. Say if you have a data like 5 MBs, or if you have a data like something like 500 KBs, right? Very small amount of data. So this is generally the size of the data set that you must be familiar with when you were using Python or R. This is the normal size of data. Very small nominal sort of data set, but you plot your charts and whatever you have to do. So that is normal data, right? So you pass it through Python and R or Java or Scala, and you can use the libraries that they have to process this amount of data, and you can get your desired output. So this is for normal data. But what if you have big data and you want to use the same languages, right? You don't want to use any exclusive language for big data or anything. Not that anything like that exists, but if you don't want to use anything, if you don't want to learn anything new, you want to simply integrate big data in what you know as it is in your data science or your data analytics. So Spark provides you with exactly that. Spark provides APIs, application programming interfaces, for all well-known data analytics languages like Java, like Python, like R, and like Scala, for seamless and easy integration, eliminating the need for training for newcomers, right? So basically, you'll use the same logic. You'll use the same logic as you were using with Python, and you'll use the same logic as you were using with R. You will simply import a bunch of libraries for Spark. If your system has Spark configured onto it, you'll just import a bunch of libraries for Apache Spark. And then you can simply pass big data sets as well in your query. If you pass big data sets in your Python and R, normal vanilla Python and R, they would have given an error, or they would have taken a lot of time to execute that output because they were running on single node systems. When you use these libraries with these Spark libraries with these languages, you can essentially take advantage of the multi-node Hadoop cluster or multi-node big data cluster that you have. So you write your normal Python script, you import a bunch of libraries, you run that Python script, you run the Python commands, and you'll get that output at a much faster rate, similar to what Spark can provide you. So that is the advantage of using the Spark APIs with these languages like Java, Scala, Python, and R. So I hope that makes it clear for that particular topic. Okay. Do Spark, vanilla languages, and Hadoop do the same work with different speeds? Yes, exactly. So if we are lucky and the vanilla code does not give any errors, so say if we have like a 1 TB file, 1 TB CSV file, right? And we simply pass it in Python using pandas. We create a data frame out of it, 1 TB file, right? We pass it in pandas without using anything else, right? We create a data frame out of it. Either it will simply give us an error because we don't have as much RAM on our system, right? Or if there is some sort of workaround to that, it will execute really slowly because your CPU is not capable of basically handling that big amount of data it'll basically take a lot of time to execute and give you the output. Even a simple +1 on all of the column values will take a lot of time when you're dealing with vanilla scripts, essentially. So, and Hadoop MapReduce obviously can do it a lot faster, but it'll still take a lot more time when compared to Apache Spark, right? So yeah, there is a speed difference essentially at a fundamental level between vanilla scripts and Hadoop MapReduce and Apache Spark. So I think this is clear why we use Spark API libraries with big data and why we use vanilla scripts with normal data. So this is what Spark helps us with. So let us understand the workflow of Spark, how to query data files. How do you actually query data files with Spark? So it's a very simple Java-based model. So a data frame is something that you need to familiarize yourself with when we're talking about, particularly when we're talking about Spark. A data frame is a data set organized into named columns, right? It is conceptually equivalent to a table in a relational database or a data frame in R/Python, but with richer optimizations under the hood. So one thing that you need to note specifically is that when you are creating a data frame with pandas as opposed to when you are creating a data frame with Apache Spark, there is a difference. So when you're creating a data frame using the Apache Spark libraries or API, what happens is the data frame is optimized for big data. So the data could be spread across multiple nodes. The data frame will pick all of the data up. It will pick the data up from all of the 6 nodes and give you a combined view of that data. A normal pandas data frame cannot do that. So you can essentially use that data frame like a relational database. You can run SQL queries on it like we are going to be doing today. We are simply going to be importing that data frame, importing that data set using PySpark, and we're going to be running SQL queries on it using PySpark essentially. And so it is conceptually the same, but there's a fundamental difference that is there are richer optimizations provided when we're dealing with big data when we're using Spark APIs. So the workflow is as follows. You have your raw data. Now, this raw data can be semi-structured or unstructured or even somewhat structured as well. So that is a different case entirely. We're going to be talking about semi-structured or unstructured today. So example of semi-structured would be CSV files or JSON files, where you don't exactly have SQL tables available to you, but you have files in a particular format, like in CSV files, which is an abbreviation for comma separated values. All of the files entries all of the files data points are separated by commas. So the comma is a delimiting value that separates all of the data present in your text file. So that is semi-structured because it at least has some structure to it. In unstructured, you can basically write up a random sentence, and that would be your unstructured data because it does not have any order associated to it. It's just a combination of words put in a random order. So that is unstructured because it does not have any structure to it. Say if you have a raw data, unstructured or semi-structured, you use anything like you use something like Python or you use something like Scala with these Spark APIs. What will happen is when you import it, it will create JVM objects, right? This is the Java virtual machine objects because Spark runs on top of Java. But the libraries are available for Python, R, Java, and Spark. But Spark at a fundamental level is coded in Java, right? So it will create JVM objects. Now, these JVM objects can be treated as rdds. These are resilient data sets. And then you can specifically pass a function called the toDF function, and you can convert them into a structured data format. So now this structured data format is in the form of an SQL table, and these are called Spark data frames. And then you can simply run, as you can see over here, you can run Spark SQL queries on these Spark data frames, and it will function in the exact way as an SQL table would, and you'll get your query results. The advantage, why are we not using MySQL? Why are you using Spark? We are using Spark because it is very well optimized for big data, while your MySQL is not at all optimized for big data. So this is the entire reason we are using Spark data frames, that we're not using Python data frames and we are not using MySQL data tables, essentially. So Spark SQL context is created to run string-based SQL-like queries on Spark data frames. So what we are going to be using today, we're going to be using the Spark SQL context with our PySpark libraries, right, today, to analyze the data today. So let's continue. So we're heading on to the demo, but a few quick things before the demo. When we use Spark libraries with Python, the combination is termed as PySpark. There is no such language as PySpark. Basically, you're using Python, but you're using the functions available in the Spark libraries. So that is casually termed as PySpark, but it's simply Python with Spark. And we're going to be using the PySpark in action with the help of Jupyter Notebook, right? So we're going to be executing it. So if you have done Python before, you know what a Jupyter Notebook is. In all probability, we're going to be doing just that. So we're going to take us there in R. So one question is being asked: where are the data frames stored? The data frames are stored in the RAM. The data frames are stored in the physical memory temporarily. As long as your Spark job is running, the data frames will be stored in the physical memory, basically. What we are going to be using today for our Jupyter Notebook implementation is Google Colab. So if you know, Google Colab is something like this. You can simply go on to this website and you can start coding in your Jupyter Notebook. You don't need to install anything new. If you're doing some minor things, if you're doing more complex things like big data analytics projects and stuff, then this Google Colab is not recommended in that case. Then in that case, you would use your own system, or you would use something like a cloud system, right? Like your AWS or your Microsoft Azure Databricks or something like that. So since our data set today is going to be small, because we're going to be just demonstrating how Spark works with data sets in general, we're going to be using Google Colab. You can do the exact same thing with Google Colab as well, right? You can take a screenshot and you can essentially enter it, all of it over here. So the first thing, I have written down some statements beforehand. So these are statements that help us set up our PySpark session. So since writing all of this by hand would have taken a lot of unnecessary time, we have simply written it down beforehand. So the first thing that we obviously have to do, you need to have Java installed onto your system. So the first thing that we did was install Java, open JDK 8. JDK 8 is the version that is compatible with Hadoop, and it is the version that is compatible with Apache Spark as well. So make sure you have JDK 8 installed onto your system. And then we have simply provided the link to the library of Spark that we are going to be using, which is the Spark 2.4.7, which is compatible with Hadoop 2.7. So this is what we're using. Although this is not the latest version of Spark, the latest version of Spark is Spark 3, but we're using 2.4.7 because, in my opinion, it is the most stable version of Spark, right? And then we've extracted it, and then we've simply installed Find Spark. Now, Find Spark is a tool that helps Python find out that a Spark framework exists on the system. So when you install Find Spark, it will basically initiate a session with the Spark libraries. So we're going to be using that as well. The next thing that I have done, first I'll play this so that this actually executes first. So it will take some time to actually happen. There's a question, do we need any Java knowledge for this operation? No, not at all. You do not need any Java knowledge. You can get started with R, you can get started with Python, you can get started with Scala. Without having any developmental knowledge, you can simply write these simple statements that are used for data analytics. You don't need to actually develop an application or anything. All of those things happen. You can simply execute your big data queries. Even if you're coming from a normal MySQL background, your normal SQL background, essentially, you can still get into PySpark because PySpark helps you with the SQL context, which we are going to be using today. So aside from some commands in PySpark, you do not need to learn anything new. So you can use SQL context with PySpark, and you simply write SQL commands and it will still execute what you want it to execute. So this takes some time because we're downloading a lot of things. Once the download has been completed, this will simply stop rotating over here, this buffering sign that we're getting. SQL, yes, SQL is necessary. So if you're getting into data analytics, right, you need to have clear understanding of SQL. Even if you're doing normal data science with Python, a SQL knowledge will always help. And it is one of the most universally known languages, SQL. So even if there is a language barrier, somebody uses R, somebody uses Python, but it is a general trend in the data analytics slash data science community to know SQL. So that is a common place for every data scientist and data analytics expert. SQL is something that I would recommend you all to understand very, very carefully and very nicely. on top of other language. So for somebody who's somebody who's specifically dealing with machine learning, right? Then I think SQL is not as important, but still SQL is very easy to learn. I think everybody should learn it because sometimes the use case for SQL will always pop up in a professional environment, in a personal environment. If you're doing a personal project, there might be some use of SQL that will always pop up. So it's always handy to know. You don't need to learn it. You can simply Google it and search for the material online as to what you have to do. But you need to be comfortable with it. You shouldn't ignore it, essentially, is what I'm saying. Okay, this has executed. Now we will set the paths. So setting the paths in my temporary Google Colab. So I've set the paths, right? And then I'll simply start my Spark session. So I have imported find Spark similar to the manner you will import it in Python. And then I've simply initiated the location and the name of what I'm actually going to be using. The Spark home has been configured and I'm going to be using find Spark init to initialize that. And then after the find Spark has been initialized, we have our PySpark available to us. And from PySpark.sql, we're going to be importing the Spark session and we're going to be starting our Spark session. The variable will be Spark. These are very complicated terms. So do not confuse yourself with all of this. If you decide to get on with the course, if you decide to get into the course, all of this will be very clear to you. But for now, we're only looking at how to data analyze, right? So let us just generate the session. So once we play that, it will take some time, but it will start up our session, right? So I'm getting a lot of, some people are from a machine learning background and some people are coming from their data science background. So they're asking as in what sort of knowledge base do they need to have in big data when they're basically going on with their machine learning and deep learning and whatever. So it is a general, if you're from a data analytics background, right? So if you're implementing something like machine learning or deep learning or artificial intelligence or data science, you all must be familiar with the fact that data sets really matter. The data should be really good. And the more data that you have, the more clean data that you have, the better will be your machine learning model, the better will be your artificially intelligent system, and the better will be your insight that you get from your data science project, right? So it depends on the quantity and quality of data. So big data as a technology that if you learn big data, if you understand how big data works, you can integrate it with machine learning, right? Once you integrate it with machine learning, you can create even more accurate, like pinpoint accurate machine learning models. So the big data knowledge in the machine learning environment and the data science environment is extremely helpful. So I will recommend everybody who is in the machine learning and deep learning environment to enhance your skills by understanding how to use big data sets. We see Hadoop in the code. Any info on that? So if you're seeing Hadoop in this code, so that is simply the file name. We're not actually using any Hadoop particular statements. We're not using Hadoop libraries. We're using Spark libraries. Spark essentially runs on top of a Hadoop framework. So, but we are using Spark. We're not using Hadoop library. Okay. So the next thing I would do is show you how data frames work. So I'll simply use the Spark session to create a data frame. It'll create a data frame essentially where we're only seeing the top 3 rows of a data frame that has the column name hello, and all of the values corresponding to that column name are world, up to a range of 1,000, right? So we're only seeing the top 3 rows. But if we simply remove this and put it into 100, we'll see world, up until 100 records, essentially. So let us continue now. So the next thing that I'm going to do is actually I'm going to be importing a file that I have personally on my system, and I'm going to be analyzing that. So the topic for today is analyzing data from different sources. So I'll tell you how to especially access those different sources. So I'm going to be accessing something from my own file system, and I'm going to be putting it on the Google Drive file system, and then we are going to be analyzing. So first thing, Google Colab helps you with this library where you can import files when you're using their platform. So I'll simply play this and it will simply pop up a screen. I'll get a screen and I can choose a file that I want to upload. So I have this data set called sudo facebook.csv, right? So we're going to be using that. So once I click that, the file will be uploaded. We'll see when it's uploaded 100%. Now, right now it's a 2% upload. So once it has been uploaded 100%, we can carry on with our next statement. So it takes some time to actually download, upload. let's say a file that is 521,7,000 bytes. So that is about 5 megabytes. So yeah, it has been uploaded 100%. The file is there, and this will start executing in a minute. Once the stops executing, we'll execute our SQL statements with PySpark. So yeah, our statement has finished executing. We have successfully put our file onto our Google file system. And now we'll simply create a code block and start with our programming or data analysis, not programming, essentially data analysis. The first thing that I'm going to do is create a data frame. So I'll call this df again and equate it to spark.read.format. The first thing that I need to specify is the format. So format of the file is CSV option. So I'm going to be adding a few options. Firstly, I want to include the headers because the CSV file has headers. So the column names essentially are headers. So I'm going to put that value to true, that yes, my file does have headers. Use the headers. So these are more technical aspects, particularly related to if we are actually accessing this entire data set as a schema. So yes, I want to do that. So I'm putting that value as true. And then we're going to put a data mode, which is going to be fail fast. So in case of any data loss, the data is going to be replicated and recovered. So put that into fail fast mode and load, and then we have to provide the location. So the location is the present working directory. Since we've already uploaded the file, we simply need to write the file name. So that does that. I think we should be good to go. Yeah. So we can play this and it will create our data frame out of the file present in the Google file directory. Yes, it has played successfully. And if we simply write something like df.show and put in something like 3, we get our output. So we can see how the data frame looks like. So the first column name is the user ID, which is the unique identification number of each individual on Facebook. We have the age of that individual. We have 14, which is the age. 13, I think, is the minimum age limit for Facebook. So we have ages 14. We have the date of birth of that individual. We have the gender. We have the number of days the person has been on Facebook. We have friends count, right? We have the friendships that person has initiated. So the friend requests that the person has sent. We have the amount of likes that the person has made. We have the amount of likes that have been received by that person. And all of this data has been divided into 4 more columns, which is how many of these likes are on mobile devices and how many of these likes are on web browsers. So we have a very definitive data set for Facebook, and we can perform a whole lot of analytics, like real case analytics with this data. So I'm going to show you just that. So one of the questions that I'm getting is, what are the other file formats except CSV? Okay. So you can use JSON as well. You can use other things as well. Say you have packet files. Essentially, you can use packet files. Essentially, Spark in with Spark, even if there is not a preset file format that is available to you, like when you write spark.read.format CSV, and whatever file format that you may personally have does not exist in the Spark libraries, there's not an issue for that as well. You can also use surds. With surds, you can also import your custom file formats as well into your data frames. So that is pretty flexible with Spark. If you do a little bit research or you're guided in the correct direction, you can implement that pretty easily. So it's not limited to CSV. All right, so let me continue. Okay, so a lot of things we can do with this data. First thing that I want to do before I actually start executing SQL statements, right, is I want to create a temporary view for this particular data frame, so that I can access that name with my SQL queries. So the first thing that you have to do is register this data frame. So create or replace temp view. And whatever name I put in here within these double quotes, this would be the name that I would refer to it when I'm using the Spark SQL context, right? So the name that I'm going to call it is Facebook data, and then I'm going to simply play this. So yes, we've successfully created our temporary view. So what are we going to do now? Now it gets really simple, especially for people who are coming from an SQL background. This can get really simple now. See, the only part of PySpark that you needed to know, especially in the case of SQL context when using with PySpark, is up until now. From now on, it is a simple Spark.SQL, and whatever query you put in these double quotes using the table name Facebook data, it will execute and give you that exact output. So this could be 5 MBs of data, this could be 5 GBs of data, and this could be 5 terabytes of data. The exact same procedure will be followed for all of those. So now you can see how Python is advantageous when we're using big data with Python, right? Because you are not essentially learning any new languages, right? You're not essentially learning Scala. You know Python, and you can simply execute all of this with Python as well, right? So Spark SQL, put in something like select, and say I want to count the number of rows, the number of people who've registered on Facebook. I want to count the number, right? So I can write simple count, put in an asterisk over there, right? So this will count all of the rows, right? And I want to get in the table name, which is Facebook data. So once I've done that, if I simply put in a dot show and bracket open, bracket close, right? So this particular function will execute this query and give me the output. So we can see now that we are getting our output, which is 99,003. These are the number of records available in this data set. And that is exactly what we're getting, right? So you can see how advantageous this gets. Uh, if the number of records was 1 million or 2 million or 3 million, and you have a big data cluster available to you, you have PySpark installed on that big data cluster, right? And you can simply call in the Spark API and do this with Python itself. This normally you couldn't have done with a Pandas data frame. You can do it with a Spark data frame using Python. So this is the advantage of using Spark SQL or PySpark, essentially. Not Spark SQL, but PySpark. All right. So let me do something now. Let me find out the average age of male users and the average age of female users, similar to what you would get as your employer would ask you to find this out for a marketing campaign or something, right? So select SQL, and then what we will do is use our SQL knowledge to it. So we will find out average age. I think age is the correct column name, which is age over here. Right? Yeah, that's correct. Average age, and then we will put in gender. So because we are going to grouping it by gender, right? So once we grouping it, once we put in the from Facebook data over here, we put in that, and then the next thing that we can do is group it by gender, so that we get the average age for the male gender, the average age for the female gender, and the average age for the non-disclosed gender as well. So dot show, put in a double bracket and play this, and this will execute what it needs to execute. So we can see. So in the averages, we can see that the gender, okay, that is a pretty high age. Did not expect that, but okay. The average age for the people who have not disclosed their ages is 74 years. The average age for the female Facebook user is 39 years, and the average age for the male user is 35. So yeah, that was not the answer that I was expecting, but that is the case with data analytics. You run these use cases on it and you get that appropriate output. So we generally know that people in the mid ages are generally more active on Facebook, create more accounts on Facebook. So it has lost sort of that earlier on when, say, we were dealing with the entry times of Facebook, right? Essentially, where younger people were generally more on Facebook. Now we have transitioned from Facebook. Younger people have transitioned from Facebook to Instagram. Right now, people in their 30s to their 40s and 50s are generally creating more accounts on Facebook. So it gives a lot of insight with relates to gender dynamics and age dynamics when we're talking over these particular things. So let me do something else. What if I do something like Spark.SQL? So we'll find out the average number of friends per gender as well. So let us see which gender at an average has the most amount of friends when we're talking about Facebook accounts in general. So average, we'll see over here, which is the friend underscore count. So friend underscore count, right? Just a moment. We don't have to put a double quotes over there. Yeah, so friend underscore count, and then we put in a gender over here and from Facebook data and group it by gender as well and show, and we play that up and we can see the average friend count for each of these genders. So we can see at an average, the people from a non-disclosed gender have 184, females have 241, and males have 165 friends at an average on Facebook. So let me look at some of the queries. All right. Sanjeev is asking, can we run a function or stored procedure? Absolutely. So that is the advantage that you get with Python. Since Python is a developmental language, definitely you can do a lot of things that you cannot do with SQL when you're using Python. So you get the advantages of Python, you get the advantages of big data technologies, and you get the advantages of SQL. The simplicity of SQL, the reusability factor of Python, and essentially the big data optimizations for your Spark. So you get all of those things in one package itself. So that is the advantage of PySpark. You can write all of this in a function and it'll execute it. You can pass the data frame in a function attribute and it'll execute it in the same way. So you can see how easy it gets. These are all essentially objects. You're passing objects and functions, and objects are treated as objects as such. So no issues with that. Let me look at some other. So one question is, what will happen if we read this data with pandas? So first of all, this data, particularly with pandas, you can absolutely execute because this is only 5 MB of data, right? It's not a large amount of data. But say if you have data which is upwards of 1 TB, right? You don't have enough RAM on your system to be executing your particular query. If it does not give an error for some reason due to some optimization that you may have put in, it will certainly take a lot of time to execute. So you cannot do this with pandas for big data sets. That is certainly not recommended. Spark SQL, yes. So one question is Spark SQL also useful with Scala? Yes. You can use Spark SQL with Scala just as well as you can use it with R, or as you can use it with Python. So it's pretty easy to use with all of that. You can also use particular things that are exclusive to these languages. Scala might have some exclusive attributes and Python might have some exclusive attributes. So you can combine the abilities of matplotlib, so to speak. So if you have something like matplotlib in Python, you can combine the usability from matplotlib with your PySpark code, and you can essentially chart your data sets as well. So that is another advantage that you get with when we're talking about PySpark. Right. So yeah, you get that advantage with R as well, and with Scala not as much. So you have to assess essentially what your use case is. You have to assess that, and you can do it accordingly. So there are also machine learning libraries available with PySpark. So mlib, Spark mlib, you can simply use your Python, which you are very familiar with when you're dealing with machine learning, and you can implement the combination of Spark's mlib with Python, and you can create your machine learning models as well. So that is pretty easy as well. Do not need to learn anything new, just new functions, nothing else. Let's look at some other doubts. So one question is being asked, what engine is the SQL context using? So yeah, a common misconception might occur, which says that we using an SQL server over here, or are we using simple Spark? So we are not using an SQL server here. What the SQL context that we are using, this particular aspect that I just imported over here, you can see the PySpark.sql that I'm using, right? It's simply an extension of Spark. It's not at all related to any sort of relational databases. So we are mimicking how SQL runs like. We are mimicking it. We are not actually using any SQL databases, or we're not using any SQL libraries. We're mimicking the functionality of SQL. So Spark basically helps people to use simple SQL commands with Spark. We are using the Spark engine to execute all of this. We're not using any SQL related, actual SQL, we're not using any of that. All right. So we can see that, and let us continue now. So all of this minded that whenever I close this particular tab, right? Whenever I close this tab, all of this data will be lost, right? In SQL, it wouldn't have been lost. It would have remained there in the relational database. But in this particular case, the data will be lost because it's a temporary. It's stored in the RAM. It's stored in the RAM of this particular Google Colab instance. And once I close this, the data will be lost, right? So say, let us do something else other than that, right? Spark.sql, and let us find out at an average, what can we find out? Let me look at it over here. So let us find the amount of users on Facebook. Do they use mobile phones more, or do they use computer devices more, right? Do they use desktops more or laptops more to access Facebook? So this is something that is also possible. The logic for that is I can simply see the mobile likes, and I can simply see the www likes, and compare both of these, and we can simply evaluate from that whether a person is using mobile phones more, or whether a person is using their browsers more, like their computer browsers more. So how do we go about that? Select mobile like, and that's that. Mobile likes. Okay, mobile likes. Select www underscore likes. Okay, and we can simply put an average over here as well. So do that, and from Facebook data, forgot to put in a double quote over here. That is important. Because you're essentially passing an SQL command, right? That is what you're doing. That is why you need to pass it as a string instead of something that is inbuilt in, say, PySpark. And we can also add a few more things to it. Let me think what we can do over here. So let us put some age demographic onto it. So let us find out this particular thing, where age is greater than equals to 13 and age is less than equals to 35, right? And we can do that, and that is how SQL functions. And we close that up, put in a dot show over there, bracket open, bracket close, and we play that up. So we get this particular data from this particular age demographic, which is 13 to 35, right? So in the people who are 13 to 35, we can see that at an average, there are 113 likes per account, and at an average for the web browser, for the computer web browser, there are 45 likes per account, right? So this basically shows that people use mobile phones more than how much they use web browsers, because obviously mobile phones are more handy, right? But let me see if as we get to a higher age demographic, does it change? Right. So I think it's not going to change, because I think people from all day age demographics tend to use mobile phones more today. But let me confirm that. That is what data analytics is all about. And given a age demographic that is above 35, and we put a play over there, so we can see that it's the same, except obviously the activity is a lot less, but it's the same. 94 likes per mobile device, not mobile device, per account on the mobile, and 57 likes per account on the web browser. So we can see that. So one question is regarding if we have Hive HBase, then why Spark SQL? Because we run Spark on top of Hadoop. So Hive and HBase are generally run on top of Hadoop as well. In fact, Hive absolutely needs Hadoop to run. Hive uses MapReduce to execute. It does not execute without using MapReduce. So whenever you run a query that is complicated, that is not simple select query, right? If you're actually analyzing the data, if you're actually performing some sort of evaluation or querying in that actual statement, then you have to use MapReduce to execute that. Hive functions on MapReduce, even HBase. So that is why Spark SQL is faster than Spark is essentially faster than MapReduce. That is why we're using Spark SQL instead of using Hive. So generally, that is the practice. It depends on how much RAM you have. If you don't have much RAM, you'll use Hive. If you have RAM, you'll use SQL. I mean, not SQL, Spark. All right. So one question again, I'm being asked. It's a how do we read the data with pandas? So yes, you can read the data with pandas. It will most probably give you an error. So, I mean, I think I made it clear. If the data is of a larger size, a very large data size, that is greater than your RAM, much greater than your RAM, your computer will not be able to deal with it. It will most probably throw an error. If it does not, it will take forever to do it. So, yeah. All right. So we've done that. And similar to that, we can perform other queries as well. So we do something else. We've taken out averages a lot. What else can we do with this data? Just a moment, guys. Short. Let us just simply find out the trend of age and friends count as well before our course advisor joins us. Okay, so let's continue with that. Sorry for the delay. Just a moment. Do I need to do I need to code every time I lose the session, right? So you don't need to do that. So with that is the thing with about using these frameworks, like you have your Google Colab over there, or you're using some sort of an offline Jupyter notebook, or if you're using scripts, like you're writing some script in Sublime Text or Atom or Visual Studio Code, you write that script, right? What I mean by runtime over here is that during the execution of the statements, right? That is the runtime. And if I simply end the session right now, the data that is being stored in the RAM of this particular instance will be lost. These statements will not be lost. I'll have to simply play them once again. So say if I close this particular session right now, if I click on the close button, if I come back and I simply don't play all of this, if I don't play this, if I don't play this, if I don't play this in sequence, and if I simply directly go over here and play this, right, it will not run. I'll have to play this in a sequence for this to actually get into an active session and have the data in the RAM. We have our data frame initiated over here, and we have our temporary view created over here. We need to do all of this before we can actually run this particular statement. Is what I mean by not losing this. Is what I mean by losing the data when I lose the session. Because in Spark, the data is stored in the RAM. It is not stored in the hard drive. So make sure if you're using something like Google Colab that you don't end your session if you still have some queries to go with. Otherwise, you'll have to go through the hassle of running it all over again. So yeah, all right. So what else can we do with the data? So let us see. I think we pretty much understand the gist of it. I think we've pretty much gone through the gist of how all of this functions, right? You can run anything in a normal SQL format. There are a lot of functions that you can run, not just the average function, something like Spark.SQL. So if you're familiar with SQL, you know all of these. So select. How do we go about it? What if we do something like friend underscore count, and we simply do something like user, I think, ID. So user ID, yes, underscore count user ID from Facebook data order by, and we put something like friend count, right? We do that and we put a show over here. I think this should run. This will put it in ascending order of friend count and user ID. I think if we put a DESC over here, I don't know if it's before the friend count or after the friend count, but I'll play this just to see. So if we put it in DESC, so we can see that the maximum friends that a person has, at least in this data set, is 4,923. And that is of this particular user ID. So we can also do that. We can sort the data as well, and you can understand how long it would take to sort this data if we are simply dealing with vanilla scripts, vanilla systems. And when you're using Spark, you essentially have your data divided into multiple, multiple nodes, multiple blocks. All of those nodes will execute their respective blocks, and the data will be sorted in a much faster manner, right? Because you're essentially doing a form of parallel sorting, and then all of the data is combined at the end and aggregated, and then you get your sorted data. So you can imagine sorting is a very expensive task, and how long it would have taken to do this for a terabyte worth of data if we were simply using pandas for that. So we can see how it functions. We see something else. We can also use something like sum. So I simply put it over here and put in Spark .sql and select some friend count from Facebook data. So put that over there and show it, and we play it. We can see that the sum of the friend count is 194,39317. So we calculated that pretty much instantly.
All right. Thank you for your time. Bye bye.